Thank you all for coming despite the delightful weather, which I thought I moved away from Canada and I wasn't going to have that anymore, but Boston has decided to make me feel like home, so thank you. How many people use PySpark? Awesome. Okay, this is actually going to hopefully be useful to you then. That's awesome. Yeah, I'm Holden. My preferred pronouns are she or her, and I just became a committer last month, and I'm so excited about that. Thank you. And I'm a principal software engineer at IBM's Spark Technology Center in San Francisco. If anyone wants to escape the snow, we're always recruiting. And I've been at a bunch of other companies like Alpine and Databricks and Google, working on similar problems, not always with Spark, but pretty similar. And I am a co-author of a few Spark books, and I have a new one coming out, which I got slightly better royalties on, so I'll try and get you all to buy that one. But if you don't want to buy my books, there's a slide share, and you can connect with me on LinkedIn or whatever it is, too. I'm also, America's been making me really sad lately. And if you don't know other trans people, I'm trans, I'm queer, I'm Canadian. There's people like me and we're really sad. And if you're maybe like me and kind of sad with what's happening with the world, you can just come find me and we can just hug. It'll be okay, we'll get through this. But if you can vote in this country, please vote next time you have an option and not for people that hate me. I would really appreciate that. Thank you. That part of my talk is not endorsed by my employer. But we do have a nice rainbow logo, so we got something going on. So the Spark Technology Center is in San Francisco. We work on a bunch of things. I mostly care about PySpark, which is why I'm giving this talk. But we've got people talking about Tori and other things. And there's a bunch of Spark committers that I work with, which is really wonderful and exciting. And I have a graph that implies we do a lot of work. And I love this graph because it means I keep getting paid. So this graph is really good, and if you're considering renewing your IBM support contract, you definitely should. Or if you want to buy a mainframe or whatever it is we sell, you want to buy one of those. I'm told we make the best mainframes. And you can even run Spark on them now too, surprisingly. So I'm hoping you're all friendly people. It's a Python-focused talk. I love the Python community. If you're one of the few not friendly Python people, just fake it. It's only 30 minutes. If you object to pictures of cats or stuffed animals, you're going to want to ignore the top pretty much part of all of my slides. And it seems like everyone actually knows some Spark and Python, so this is going to be fun. And it's going to be a little bit silly. So if you're expecting a serious presentation, I don't know if this maybe gave it away that this wasn't going to happen, but we're gonna have some fun with it. We're going to talk a whole bunch of stuff, but the important part is there's going to be pictures of cats. So for those of you, oh right, okay, yes. So I like to think of this as building our monster identification guide, and we've brought one of our little monsters with us. This one's name is Boo. She goes bark bark. But we've got friend monster who represents the JVM stack traces. We've got Buddy, who likes to talk a lot and represents the Spark logging messages. I don't know if anyone's noticed that. And then we've got Tubbs, and Tubbs represents the out-of-memory exceptions that you get from Python. And we're going to talk about how to find them and where to find them. And this isn't all of the monsters in Spark, right? But these are some of the most common monsters in Spark. Yeah, so very serious. But for those of you that don't know how PySpark works, it's kind of useful to understand. And if you were here for Wes's talk, you probably got a taste of it. But really, at the end of the day, Spark is written in Scala on the JVM. And making that work involves Py4j, pickling, and just a little hint of magic. And occasionally, like most magical things, the magic breaks, and then you have to figure out what the magic was doing behind the scenes for you. So let's look at some of this. On our driver-side program, our Python interpreter is actually just talking to a Java interpreter over something called Py4j. Has anyone used Py4j? My condolences. I feel we should have a support group for Py4j users. It's a wonderful library. It's the only option to do what it does, but it's painful, and you'll get some error messages from it that make no sense. And then on our workers, we use Unix pipes because they are renowned for being fast. More seriously, it's important to understand that on our workers, the data gets transferred into the JVM first, and then data gets transferred from the JVM to Python and back. And so when we get error messages, we tend to get them from Python, wrapped in the Java virtual machine, thrown back to Java again, so wrapped another time, and then wrapped once more for good measure in another Python exception. And then we only really normally care about the tiny innermost bit, but this is why we tend to get so many confusing things happening when something goes wrong. And really what it comes down to is error messages make no sense. But we're going to find those error messages that make no sense, and then we're going to make sense of them together. So if you happen to be deploying this on the console, right, you're just using Spark Submit or bin PySpark, you'll get your error messages reported to the console. That's relatively easy. The Spark Web UI is actually pretty useful because you can go and drill down into the workers and see what the error messages are from the individual workers. This works provided that your workers don't exit, and we can configure that with Yarn. And there's the Spark History Server for the fancy people who are deploying in Yarn. And if you're one of those fancy people deploying in Yarn, I urge you to consider the Spark History Server. Is anyone working in Jupyter? Okay. So the error messages were so useless, I looked up how to disable error reporting in Jupyter. This is what someone told me at PyData DC, and it made me sad. But the reason is the error messages that we get here, they're only coming from Python, right? We're getting the py4j error, but we're not getting the error message from the JVM on the driver program. So this just really tells me I did something wrong, but it doesn't tell me what I did wrong. And the what I did wrong is actually in my shell, which of course is where I would go and look for it, right? Naturally, always we do this. And so this is like, oh yeah, ends with, that's not a function. I should have used the other thing. But I have a proposed fix for it. It only works under certain circumstances. But the important thing is if you're working in Jupyter, you're going to want to double check here or in your Jupyter console logs. If you're working one of the cloud notebook solutions, they've fixed this problem for most of the cloud notebook providers, so you don't have to worry about it. But if you're working in your own Jupyter kernel, this is why your error messages contain no information. Hopefully that helps someone. If you're in Yarn, please set up the Spark History Server. It's going to make your life a lot easier. If you're the kind of person that's like, I love debugging with GDB and Python processes, you're a little different than I am, but that's fine. You can set Yarn node manager delete debug delay seconds to have it keep your container around for a while after it's failed. So you can go in there and start poking at things and be like, ooh, core dumps. This is going to be fun. And, you know, different things for people. So Spark is really verbose by default, right? That's Buddy. Buddy is our friend who talks to us all of the time. How many people have turned down Spark's logging message level? Okay, that's probably most of the people that are still awake at this point in the talk. I actually kind of appreciate the verbosity. I wish it was tuned differently by default, but you can dynamically control the log level with sc.setLogLevel. You can also configure it with the log4j properties file, but I find if I'm working in the shell, I often don't want all of those logging messages for like, I parallelized an RDD, I loaded some data. I just want to turn my logging up once I get to the part of my application where I know I did something wrong. And so I like dynamically controlling it this way. If you like writing properties files, that's fine too. But what about once we actually get our error, right? Like, Buddy normally just tells us useless crap, but occasionally Buddy tells us something useful. So our Python Spark errors normally come in two parts, as we said. And friend monster, who's our JVM stack trace, comes with all of our other errors to make sure they don't get lonely on their way from the cluster to our machine, because we couldn't have that. And Boo, because I really like Boo, Boo represents the Python stack trace that is useful, the one from the workers. And so Boo has the information inside of it. And so what is our JVM stack trace? You can probably ignore it. Unless you don't have a Python stack trace to go with your JVM stack trace, then you've probably like caused a problem in data frames or something like unbalanced key thing, in which case you actually need to look at the JVM stack trace. But if you've got like some stuff that makes no sense in a Python stack trace, go and look at that Python stack trace. So we're going to make some errors, and we're going to look at what the error messages look like. The first one I'm going to do is divide by 0, because this is really simple. And depressingly, I've written code that divides by 0 far too often. Not normally x divided by 0, normally lambda x divided by y. And then y is set to 0 because it was null, and then my life is sad. But our error message is super helpful. It's 400 lines of information about some stuff I really don't care about. Here I can see that I've got some pipelining going on, and I did something bad. Okay, so that was not, super useful. We've got 400 lines reported back to my console, and all of the interesting stuff has probably scrolled by before I had a chance to capture it, unless I'm running in a screen session. So okay, maybe that's not going to be how we debug this. Let's go to the web UI. Yay! So incidentally, it's useful to notice that our web UI doesn't contain as much information as if you were working in Scala. When you're working in Scala, you get really nice visualizations of your directed acyclic graph. In Python, we do a bunch of pipelining magically before we hand it over to Scala, and then Scala generates the nice visualizations. But because we did a bunch of pipelining before we gave it to Scala, Scala's just like, so I have a thing, and then I do thing 2, and then we do thing 3. And I'm like, but what's thing 2? And it's like, it's a thing. Why are you talking to me? But it's okay, because we get failure reason. So we're going to click on that, because failure reason, that looks promising, right? Okay. Looks promising to me. So I click on it. I'm like, okay, cool. I've got my driver program. I'm going to scroll down. Oh, I've got 400 lines of errors again. Okay, well, that's fine. That's fine. We'll scroll. We'll scroll. Not quite to the bottom. If you scroll all the way down to the bottom, you get another useless JVM stack trace. But just above the last useless JVM stack trace, you receive information. Yay! It says I divided by 0. We knew that was coming, right? But what matters is, like, if you're looking at this, if you look at the error message which is reported, you can look at the python.python exception and look for where that shows up in your logs, and there's a good chance you're going to find your actual stuff that you care about close to that. And that's going to be how you find the bits that you care about. Or, we could, if we were in the console, like scroll around and look for it. And then we can find this thing, right? And this doesn't contain any information useful yet, but it does down here, right? So if we scroll a bit more, if we search through our 400 lines in our screen session, we can actually find our exception. And I think, this is interesting. The Python pipelines happen for performance. It's really important that we do the pipelining inside of Python so that we don't copy data a lot of times. So it's not something that we should really try and get rid of, but it does make it a bit more difficult to debug, right? Because if this was just regular, I would have something much more reasonable. But here, I have this map partitions with this for some, and I'm like, I don't know why that code is failing. And I didn't write that code ever. What? But it's okay, right? It gives us performance, so we accept the fact that it gives us shitty debugging experience. But you can work around it by caching your intermediate RDDs before your failure and forcing evaluation of those intermediate RDDs. And then PySpark won't shove all of these things together and pipeline them. And then you can actually just get the part which is failing and just look at the error message related to the part that fails. And you can actually have a happy time this way. Take one and count are your friends. I mean, they're your friends, but they're kind of your friends that steal your lunch money. But we keep going back to them because we don't really have any other friends, and it's kind of sad, but you work with the friends you got. Sorry, this is giving me flashbacks. We're going to move on to happier things, and that is lambdas. Lambdas are not our friends always. I like writing lambdas in Spark. I am a functional programming nerd, and like writing Lambda, always I'm just like, yay! But the problem is it makes finding our errors a little more challenging. If we name our functions, we can grep for our function names in our logs. The other thing that we could actually do is we could just refactor them and test our expressions on their own without testing them inside of Spark. And then you don't need a fancy Spark testing library to test your functions. And that's really useful. If you're trying to debug a function, there's a really good chance that when you're done, you should be writing a test for that function anyways, because something has gone wrong. And you know, it's difficult to put our own logging inside of a Lambda expression in Python, just because of how Python is. You should totally do testing. Even if you don't refactor your code, I have a testing library that I would like everyone to use so that I can keep getting time to work on it. It's published on pip for the Python people. You can just pip install it, and it'll make your life possibly easier. If it doesn't, don't tell my boss. And there's a talk on it on YouTube, and you can just search for like Holden Spark testing library. But we should add our logs, right? We divided by 0, so that wasn't super surprising, and like we had a straight up divide by 0 in there, so like that wasn't going to be hard to debug. But if we had a lambda xy and we did some complicated thing with y, we might actually want to know what the different values were when we were failing in our inputs, right? And so we should add some logging information so we can know what inputs we're failing on. Has anyone used Spark accumulators? Once again, I'm sorry. But Spark accumulators are actually pretty useful for debugging. I don't think they're super great for anything else right now, but for debugging, they give us some insight without having to like completely re-architect our code. So let's look at how we can use an accumulator. The other thing is, this is clearly a hard error. Dividing by 0 means like bad news bears. But not all of your errors are going to be hard errors. If you're loading input data, you probably want an idea of what's going on, but you're probably going to reject some of your records. Like, that's just a fact of life. People that give me JSON schemas are always liars, and they're probably lying to you too, right? You're going to want to reject the records which don't look like what you expect, but you know, keep a record so you can understand when someone's like, yeah, what you told me is like 10% wrong, it's okay, versus what you told me is 90% wrong, I'm not going to use your data. So we can use accumulators. Woo. So we have our exciting logged divide by 0 function here. In this case, it's going to fail 100% of the time, but for your own code, hopefully it doesn't fail 100% of the time, and this logging information will actually be useful. There are some examples on Stack Overflow of people trying to use the Py4j logger inside of PySpark, and that will work when you're in local mode, but it will not work when you deploy to a cluster, so please do not do that. Use your friendly Python logging library called logging. It's called logging. You can, if you're going to be dynamically tuning your log level, you probably want to do that by using sc.add file to distribute a logging configuration file to your workers, or just add it manually. Here, I'm just doing it by default. But your log messages, in this case, will actually just show up in the standard error and standard out by default, and those actually get captured by Python RDD and written out to the log files in your Spark workers. So you can go and find these log messages in the same way that we found the log messages in the web UI earlier. So we can actually get these log messages too. In this case, it's just going to tell us we rejected all of our input and we should probably not be dividing by 0, which is not that surprising. And we all know Spark accumulators are a little shaky. If you don't, Spark accumulators are a little shaky. Don't use them for real. I totally have a plan to fix this. And I'm actually going to fly to Chicago and try and get someone to finish reviewing a PR. I'm coming for you. If you're watching the live stream. If you're not, it's okay. It'll be a surprise. Has anyone used -mtrace to debug their software before? Okay, no one that I can see. So that's fine. You're not going to be disappointed. It doesn't work, so don't use it. I've come across people that have tried to use it, and then they get sad, so I can save you disappointment. Out of memory, yay! We're gonna have Tubbs help us out in this one, and Tubbs is gonna tell us what's going on. So here I've got a memory error down at the very bottom. I should have bumped up the font on this, but essentially this is a classic Python memory error. I'm doing something stupid. I'm just allocating way too much memory. But I could get this in a lot of other ways too. And the really tricky part about tubs, who is our out-of-memory monster, is that tubs doesn't always look the same. And it really depends why we've run out of memory. So sometimes tubs has eaten too much food, sometimes tubs drinks too much coffee. Sorry, okay, no one laughs, but that's fine. We'll be more serious. We can get an out-of-memory error, and it'll just be a JVM GC time limit exceeded or out-of-memory exception. And this can happen when you're doing simple stuff with UDFs. This can happen if we've got an unbalanced shuffle and we're simply sending too much data to one worker. If we're doing something silly inside of our Python code, like we ask pandas to allocate a data frame that's too big, we'll probably get an out-of-memory error. But if you're in Yarn, you might get application overhead exceeded, which is really useful and definitely says you use too much memory. So when you see application overhead exceeded, that probably means you use too much memory. It might also mean it's time to play with your Yarn configuration, and good luck. You can also get an out-of-memory exception on the driver program. Has anyone got that? Yay! So there's a bunch of ways this can happen, and some of the ways are related to our good friend Py4j. And the problem is essentially we have two separate garbage collection systems, and one of them has objects that are pointing to the other one and uses reference counting, and the other one uses mark and sweep. And this goes really well in that it doesn't get rid of objects very often. And so what happens often is you accidentally have a JVM out-of-memory exception because some Spark code is doing something silly. So if you see this, there's like at least a 15% chance it's my fault or the fault of one of my friends, in which case you should totally talk to us on the mailing list, and we'll probably blame you for a little bit and then later on admit it's our own fault, and then we'll fix the bug. But it could also be some fault in your code if you're doing something really weird. But essentially, you should probably do a JVM heap dump and look at what's going on when you get into this case. Yeah, so there's a bunch of reasons for this to fail. If you're using PySpark with UDFs, there's a bunch of sort of magic that happens behind the scenes to transfer minimal amounts of data in between the JVM and Python, but this also involves buffering giant amounts of data inside of the JVM to rejoin it after it's been in Python. And it turns out that sometimes we get that buffering wrong. And so that's not your fault, but we're probably not gonna fix it real soon. So you're probably gonna have to do a workaround, and that's just like select your data down and then manually rejoin afterwards. If you've got like really big records, it's probably just going to explode. As Wes McKinney showed, like 128 megs of input can quickly become 2 gigs of resident memory. Oh God. So give your executors lots of memory. They'll thank you for it. Yeah, okay. Yeah, there's a bunch of things, whatever. All these things are not my fault, so I care less about them, but you might care about them because they're probably things that you can fix instead of me. Anyone use map partitions? Okay, so the three of us can talk afterwards, and there's some stuff that you have to know. I mean, you already know it, but the rest of us. Loading invalid input paths is one of the cases where we actually just get friend monster. And so this case, if we ask Spark to do something so wrong that it doesn't have to actually get to executing any of our Python code, we'll just get a Java stack trace. And that's really awesome because the Java stack trace, while not making a huge amount of sense, has the information up at the top, and we can just ignore everything else about like what the hell get partitions inside of Hadoop RDD, right? So if you actually just get a JVM stack trace, it's probably good even if it feels like someone's not being nice. Because the JVM stack trace means like you only have one thing to worry about, and the error messages tend to be easier to understand than a Python stack trace wrapped in a JVM stack trace, wrapped in a Python stack trace, wrapped in a JVM stack trace, wrapped in a Python stack trace. I think I got that right. So this is pretty simple. If we load some invalid data, we're going to just get a JVM error. And so we're running out of time, and Boo found a bunch of food, so we're going to wrap up really quickly. Yeah, so if that's not enough to debug, you can do the sad thing and just move take one up your dependency chain until you find where it's failing. Yeah. I mean, I prefer binary search, but whatever. Bunch of sad things. They're sad, so we'll skip them. Oh, right, I should sell you things. So I am the co-author of many of these books and receive royalties for some of these books. I think you should definitely buy every book where I receive royalties, except for this fast data processing with Spark one. That one's out of date, so don't buy it. Unless you just want to give me money and you, for some reason, can't slip me a 20 in a brown paper bag. Oh, actually, I did that compliance training recently. Don't slip me a 20 in a brown paper bag. There's apparently rules against receiving bribes. But I think I can tell you to buy my books. Specifically, I receive the highest royalties if you buy high performance Spark. So I encourage you all to buy several copies of this. If you have an expense account, dogs love it. And it makes a great gift for clients that don't know what Spark is, because they are unlikely to complain about it. If anyone's really interested in Python, though, Denny has an exciting book coming out, and they let me write the foreword for it, which is nice, because I got to talk about Bud Light Lime in a book. Assuming their editors don't take it out. So that's pretty much it. We've got like a little bit of time for questions. Yeah, I'll be around though. I'm pretty easy to spot at tech conferences. So if you have questions that you don't want to ask in public, you can come find me. It's okay. Like maybe you don't want to talk about your Python stack traces. It's cool.
Thank you, Holden. Thank you for that informative, educational, and yet very entertaining talk. And I just love the monster, except for Toby. I might be able to relate to the guy who actually talks a lot. So do we have any questions? We got about a couple of minutes left. The two mics on either side of the aisle. You can probably just walk up to it. Well, then just buy some of her books then.
Yeah, several copies.
Several copies, yes, yes. Well, we'll meet you back here in half an hour for coffee, so enjoy yourself and thank you. Another big hand for Holden, please.
Thank you.